जो है 16 साल जो है वो
गुड इवनिंग एवरीवन। नमस्कार सभी को, स्वागत है अभी का इस फॉर्म पर जिसका नाम है वन मार्क सॉल्यूशन। हमारे यहाँ डिफरेंट सब्जेक्ट्स के सब्जेक्ट एक्सपर्ट्स आते हैं क्लास 6 से 12th के लिए, और ऑल सब्जेक्ट्स के वन मार्क सॉल्यूशन के डिटेल्स में उन सब्जेक्ट्स को एक्सप्लेन करके चैप्टर और वन मार्क्स के क्वेश्चंस को एक्सप्लेन करते हैं। और सीबीएसई में जिस तरह से वे क्वेश्चंस पूछे जाते हैं उन्हें, जैसे ट्रू एंड फॉल्स, फिल इन द ब्लैंक्स, रीजनिंग, मैच द कॉलम और डिफरेंट टाइप्स के क्वेश्चंस को एक्सप्लेन करते हैं। जो बच्चे रेगुलर इस 7 वेबिनार्स को अटेंड करते हैं उन्हें पता है कि पिछले 1 महीने से हम डिफरेंट सब्जेक्ट्स के क्लास वाइज, चैप्टर वाइज एमसीक्यूज क्वेश्चंस को लेकर आ रहे हैं। हमारे सब्जेक्ट एक्सपर्ट्स आते हैं डिफरेंट कंट्रीज के, डिफरेंट पार्ट्स ऑफ कंट्रीज से, और वे इसे एक्सप्लेन करते हैं। तो मैं सभी से रिक्वेस्ट करती हूँ कि आप लोग चैनल को सब्सक्राइब कर दीजिए ताकि आने वाले जो वेबिनार्स हैं उनकी इन्फॉर्मेशन आप लोगों को टाइम से मिलती रहे। वैसे इसका टाइमिंग होता है 4 to 5 o'clock। अगर आपको इन्फॉर्मेशन नहीं भी आती है तो इस टाइमिंग में आप आकर के चैनल को विजिट कर सकते हैं। तो आज हमारे साथ सब्जेक्ट एक्सपर्ट है डॉक्टर हितेन परमार जी। ये पीजीटी फिजिक्स टीचर हैं राजस्थान जयपुर में। इनका अपना इंस्टीट्यूट है और ये सीबीएसई में he was also associated with CBSE ट्रेनिंग कमिटी। और आज हम क्लास 11th के फिजिक्स के चैप्टर 3 को लेकर आए हैं हमारे सब्जेक्ट एक्सपर्ट हितेन परमार जी, और वे इसे आपको डिटेल में एक्सप्लेन करेंगे। तो इसके पहले मैं अपने व्यूअर्स से रिक्वेस्ट करती हूँ कि चैनल को सब्सक्राइब तो करें ही, साथ ही आप हमारे साथ इंस्टाग्राम और फेसबुक पर भी जुड़ जाइए ताकि सारे वेबिनार्स की इंफॉर्मेशन आप लोगों को मिलती रहे, और जितने वेबिनार्स आपने पिछले मिस कर दिए हैं वो भी आप लोगों को उसका भी बेनिफिट मिल जाए। तो मैं स्वागत करती हूँ हितेन परमार सर जी का। सर, स्वागत है आपका हमारे प्लेटफॉर्म पर वन मार्क सॉल्यूशन पर। और आप अपने सब्जेक्ट नॉलेज से हमारे स्टूडेंट्स को बेनिफिट दीजिए। वेल सर।
नमस्कार मैम। सभी को सबसे पहले तो महाअष्टमी और महानवमी की बहुत बहुत शुभकामनाएं और बधाइयाँ। एक चीज़ मैम, डॉक्टर नहीं हूँ मैं, पीएचडी नहीं कर रखी है, आई एम सिंपली हितेन परमार। ठीक है, क्लास 11th फिजिक्स की हम लोग बात कर रहे हैं। स्क्रीन शेयर हो रही मैम?
हाँ, नहीं हुई अभी सर।
स्क्रीन शेयर्ड है, आपके वहाँ से करनी है मैम स्क्रीन शेयर।
हेलो सर, कोई प्रॉब्लम आ रही है?
स्क्रीन शेयरिंग में कुछ प्रॉब्लम आ रही है। एक सेकंड। अब हो गई मैम शेयर?
नहीं हुए अभी सर।
Not yet shared. मेरे यहाँ से तो मैम शेयर्ड है. एक बार टेक्निकल टीम से बात करें.
हाँ जी जी सर.
स्क्रीन मेरी तरफ से शेयर है लेकिन वहां पे नहीं आ रही स्क्रीन पे.
Sir, your slide is visible now.
Is the screen visible, sir, now?
Yes, sir. Yes, sir. It is visible.
So, sorry for the delay.
Sir. Now you can start.
If we are talking about motion in one dimension, motion in one dimension means अगर कभी भी कोई भी बॉडी किसी एक स्ट्रेट लाइन में कहीं पे भी ट्रेवल कर रही हो, if the path of the body, the trajectory of the body can be presented as a straight line, or we can say when only one coordinate of the position of the body changes with time, then it is said to be a body moving in one dimension. For example, if a body is being dropped from any height, it is supposed to follow a particular straight line path, or if a car is traveling on a perfect straight road without making any sort of turns or anything, then all such cases are said to be a motion in one dimension. Average speed, instantaneous speed, these are two very important terms if we talk about competition exams related to this particular chapter. Average speed, that is calculated by the formula total distance traveled upon total time, and it is defined as simply the ratio of total distance traveled to the total time taken. Whereas instantaneous speed generally is the speed at a particular instant. Suppose you are just traveling in a particular vehicle and at any particular instant आप एकदम से अपने गाड़ी के speedometer को देखते हैं. We just look at the speedometer, the speed at that particular instant. That is what is known as instantaneous speed, that many times can be considered as average speed for an infinitesimally small time interval. But while carrying out the calculations, while carrying out the numericals, instantaneous speed is generally calculated by integration of the acceleration expression, or as I've shown it on the screen over here, it is given by the differentiation of the displacement or position expression. The second important part, other than these two terms in this chapter, or I would say the most important part of physics in whole, is graphs. And graphs are very first introduced in this chapter only in class 11th. In brief, I'm going to let you know about some position time and speed time or velocity time graphs. The first position time graph that is there on your screen is representing a body at rest. Whenever the line is parallel to the time axis, the angle that that particular line or graph is making with the x-axis or the time axis is zero. That means the slope is zero, and such graphs represent the body at rest. But if the graph is ever parallel to the y-axis, the position axis, or I would say if the graph is ever perpendicular to the time axis, that is first graph on the screen, it is a not possible graph. We can think of it in two different ways. The angle over here is 90 degree. 1090 is infinity. That means the slope, the velocity of the body is infinite, and that is not a practically possible situation. We can think of it in one other way. A body cannot be at different positions at a given instant of time. This graph is showing the body at different positions at a given instant of time, and that is why this graph is not practically possible. In the next graph, the line is making an acute angle with the time axis, with the x-axis. If theta is ever less than 90 degree, tan theta is positive. That means for acute angles, the slope is considered as positive. In this graph, position time graph, the slope represents velocity, positive velocity, but the slope is constant everywhere. So a constant velocity or zero acceleration graph is represented in the second graph on your screen. The third and fourth graph, they represent increasing and decreasing velocity. In the third graph, the slope is continuously increasing as at various positions as we move along that curvilinear line. The angle with x-axis is continuously increasing. We can take it in one other way as well. If the curve is bending towards the position axis, it would always represent increasing velocity, and if it is bending towards the time axis, it would always represent decreasing velocity. In the last graph on your screen, the angle with positive x-axis or time axis is obtuse in nature. The slope would be negative. That means the velocity would be negative. It is a constant velocity because the line is straight. It is not curvilinear, but that velocity would be negative. In such cases, generally we refer it as the body is approaching towards the observer or the point of reference. The first graph on your screen now has a number of straight line segments with different slopes connected. OA, AB, BC, and CS are four different straight lines. But at A, B, C, the slope is changing. So O to A, it has a constant speed. A to B, it has another constant speed. B to C, a new speed. Then C to S, one more constant speed. So it is graph representing a body traveling with different velocities in different durations. From O to A, it has a different speed of velocity. A to B is a different speed of velocity, and so on. The next graph again shows two different positions at a given instant of time. So it is also a not possible graph. The third graph on the screen is the last position time graph that we are discussing or talking about. This graph shows that particle is moving towards the origin and then again returning back away from the origin, returning back. The last graph on this screen, the particle was approaching the observer, approaching the point of reference, the origin, and then crossed it through. Whereas in the graph that now we are discussing, the third on the screen, the body is moving back away from the observer, point of reference, or the origin. A very quick review of the velocity time graphs also we are going to take. The first one is constant velocity, axis parallel to the time axis, graph parallel to the time axis, theta 0. The second one is not a possible case. A body cannot have different velocities at a given time position. Third one, velocity time graph, the acceleration is represented by the slope. Slope constant, theta constant, so it is a uniformly accelerated motion, a constant motion. The curves we have already discussed, if it is bending towards velocity, it is increasing slope, that is increasing acceleration. If it is bending towards the time axis, it is decreasing slope or decelerating body, decreasing acceleration body. The fifth graph, the position, the velocity time graph, theta is constant, theta is acute, so it has to be a positive acceleration body, but for the initial span, for the initial time period, the velocity was below the time axis, so it's initiated with a negative velocity, but later on switched on to positive velocity due to the acceleration provided to it. The last graph, it says position, the positive constant or the positive slope is present over there, but initially the velocity was not zero. At time zero, the body has initiated from some value of velocity. Similarly, these three graphs also, I think it is not a big deal now to understand these graphs. I want to move quick on to the questions now. The five equations that we use for most in one dimension motion, the three equations of motion, v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as, where v is the final velocity, u is velocity at time zero, a is the constant acceleration. These equations are applicable only for a uniformly accelerated body. That means only when the acceleration is constant, these equations can be used. After these three equations, two major formulas, two most common formulas that we use in one dimension motion are s is equal to u plus v by 2 into 2. This u plus v by 2 represents the average velocity for a uniformly accelerated motion. It represents average velocity for a uniformly accelerated
सर ड्यू टू सम टेक्निकल रीजन सर डिस्कनेक्ट हो गए हैं, बहुत जल्दी सर वापस से ज्वाइन कर रहे हैं। आप सभी लोग साथ में बने रहिए। सर आप पीपीटी शेयर कर दें, स्क्रीन शेयरिंग कर लीजिए। या नाउ यू कैन स्टार्ट। Sir, now PPT is not visible again. Yeah, now it's visible.
So
Now you
now
can
I would
start.
just like to start with the questions. The very first question, starting with a bit simple ones. A body moves over one-fourth of a circular arc in a circle of radius r. The magnitude of distance traveled and the displacement will be. The four options are pi r by 2 as the magnitude of distance traveled, r root 2 as displacement, pi r by 4 and pi r, and r by root 2 and pi r, comma r. If you can look at the figure, the body is traveling from A to B or B to A, one-fourth of the circular path. So distance traveled along the curve AB is one-fourth of the perimeter of the circle. That is 1 by 4 of 2 pi r, or simply pi r by 2. Whereas the displacement is the straight line joining the points A and B. In the right angle triangle, if it is framed OAB, the two arms OA and OB are the radius of the circle. So by Pythagoras theorem, you can get it as root 2r. So option A is the correct answer. One more related to the circular path. A displacement of the point of a wheel initially in contact with the ground, when the wheel rolls forward half a revolution, will be, if the radius of the wheel is capital R, then what would be the displacement of the point of the wheel? Look at the figure on the right bottom, the two initial and final positions of the wheel. Very easily we can infer that if the wheel rolls forward half a revolution, the distance traveled on the horizontal surface has to be half of the perimeter of the wheel, that is pi r. The vertical distance on the right hand has to be the diameter of the wheel, that is 2r. Again Pythagoras theorem, and you can get your answer as r under root of pi square plus 4. That is option B is the correct answer. A question on average speed, one of the very commonly appearing questions in school level MCQ questions or in the competition exams at all levels. If a car covers 2 by 5th of the total distance with speed v1 and the rest 3 by 5th of the distance with speed v2, then what would be the average speed of the car? Look at the figure. We have distributed into two halves, time t1 for 2 by 5th of the total distance x and time t2 for 3 by 5th of the total distance x. Average speed is total distance upon total time. Total distance is 2 by 5x plus 3 by 5x, that is x. What is the time for the 2? Can we get t1 as 2 by 5x upon v1? The time is distance upon speed. So we've used that particular formula. T1 is substituted as 2 by 5x by v1, t2 by 3 by 5x by v2, and on simplifying it, you get option D, 5v1 v2 by 3v1 plus 2v2 as the correct answer. A man walks on a straight road from his home to a market 2.5 km away with a speed of 5 km per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 km per hour. The average speed of the man over interval of time 0 to 40 minutes is equal to. Looking at the question, time taken to go to the market 2.5 km away with a speed of 5 km per hour is 2.5 speed of 5 km per hour around. It gets to be half hour or 30 minutes. You have to get the average speed for 40 minutes. So now you have to calculate the distance traveled in next 10 minutes. For the next 10 minutes, the speed is 7.5 kilometer per hour. So 7.5 into 10 by 60, as it is minute and hour calculation. 7.5 into 10 by 60, that gives you 1.25 kilometers. So total distance upon total time. Total distance is 2.5 kilometer for first 30 minutes, 1.25 kilometer for next 10 minutes. That is 3.75 kilometer. Total time is 40 minutes, that is 40 by 60 r, and you get your answer as option D, 45 by 8 kilometer per hour on applying the formula. A relation between time and position or time and distance is given as 3t is equal to root 3x plus 6. It describes the displacement of a particle in one direction. X is in meter, t is in second. The displacement when velocity is 0 is. So you have to first calculate velocity from it and then get the time from it and then substitute it to get the displacement. 3t is equal to root 3x plus t plus 6 can be simplified for x as x is equal to 3t square minus 12t plus 12. On differentiating the position expression, v is dx by dt, you can get the value of velocity or the expression for velocity as 6t minus 12. Now if velocity is 0, that means 6t minus 12 is 0, then t is equal to 2 seconds. Substitute that t in the expression of x above, x is equal to 3t square minus 12t plus 12 to get the displacement as 0. So option D again is the correct answer. One more such question, the position of a particle varies with time as x is equal to at square minus bt cube. The acceleration of the particle will be 0 at what instant, at what time? Acceleration, that means you have to differentiate it twice. X is equal to at square minus bt cube is differentiated once to get velocity, then velocity is again differentiated to get the acceleration as 2a minus 6bt. When acceleration is 0, that means 2a minus 6bt is equal to 0, then t is equal to a by 3b. C is the correct option. Displacement of particle now is given by y is equal to a plus bt plus ct square minus dt to the power 4. The initial velocity and acceleration are. Initial velocity and initial acceleration means velocity and acceleration at t is equal to 0. If I differentiate y, I get the velocity as b plus 2ct minus 4 minus 8 minus 4 dt square. It is there now on the screen. V is equal to dx by dt is equal to b plus 2ct minus 4 dt square. And again, if we differentiate it, the acceleration comes to be 2c minus 8 dt. Substitute the values of t in both the expressions. Initial velocity comes to be b and initially acceleration is 2c. Option C is the correct answer. Relation between time t and distance x is given as t is equal to alpha x square plus beta x, where alpha and beta are constants. The retardation is, now it is clearly mentioned that you have to talk about the retardation in this case, but the answer is in terms of velocity v, that is not given. So firstly we'll have to create the expression for velocity by differentiating it. If I differentiate t with respect to x, I get dt by dx as 2 alpha x plus beta. And if I reciprocate it, I get the formula for velocity dx by dt as 1 by 2 alpha x plus beta. Acceleration, either I differentiate it and get the acceleration, or acceleration when it is in terms of x is also given by the expression v dv by dx. And if I apply the concept, I get the acceleration as minus 2 alpha v cube. As it is negative, it is retardation. That is what the question says the retardation is. So option A is the correct answer in this case. A concept being shown in this question, if displacement of a particle is directly proportional to the square of time, if displacement of a particle is directly proportional to the square of time, then the particle is moving with. If displacement is directly proportional to the square of time, I can take x is equal to a constant k into t square, differentiate it to get the value of v as 2kt. Displacement is depending on time. The velocity is also time dependent. Time is there in its expression. But I differentiate velocity with respect to time, I get a is equal to 2k. So a is constant as a is not depending on time. Option A says uniform acceleration. That is the correct answer. A particle is moving eastwards with velocity of 5 meter per second. In 10 seconds, the velocity changes to 5 meter per second northwards. The average acceleration. Acceleration is given by change in velocity upon time. The final velocity can be represented as 5j cap v2. The initial velocity v1 can be represented as 5 cap as it is moving towards east. It is 5 cap. Change in velocity is 5j cap minus 5 cap. Time taken is 10 seconds. So average acceleration can be calculated. The magnitude of it can be calculated as 1 by root 2 meter per second square. And from the figure, you can observe the direction of it towards northwest. Minus v1 it is there. A is equal to v2 minus v1. So it is represented westwards in the figure. Minus of eastwards is westwards. Option B is the correct answer in this case. A body starts from the origin and moves along the x-axis such that velocity at any instant is given by 4t cube minus 2t, where t is in second and velocity is in meter per second. That means SI system of measurement is being followed. What is the acceleration of the particle when it is 2 meter from the origin? When the position is 2, then what is the acceleration? If velocity is given as 4t cube minus 2t, we can get the expression for the position by integration of it. If I integrate it, I get it as t to the power 4 minus t square plus an integration constant c is applied. At t is equal to 0, the body starts from origin, the very first statement of the question. So at t is equal to 0, x is also 0, substituting the values, x is 0, t is 0, then c also comes to be 0. So x now is t to the power 4 minus t square. The last part of the question says, what is the acceleration when it is 2 meter from the origin? Substitute the value of x as 2. You'll get the value of t as root 2 second, and then you can use that root 2 to get the value of acceleration. V is 4t cube minus 2t, a is differentiation of it, 12t square minus 2, substitute t as root 2, that is 12 to the 24 minus 2, 22 meter per second square. In physics, we have fill in the blanks, we have 1 mark questions, and we have MCQs as OTQ. A body of mass 10 kg is moving with a constant velocity of 10 meter per second. When a constant force acts on it, it moves with a velocity 2 meter per second in the opposite direction. The acceleration produced in it is, if the particle is suppose moving towards east and the constant force makes it move towards west. This is what the question says. A constant force makes it move with a particular velocity in opposite directions. So I considered it to be east and west just for an instance. The acceleration in that case, what we did in the previous question, the same way, v2 minus v1 by t. v2, final velocity is 2 meter in opposite direction, 2 meter per second. So it is minus 2 minus the initial is 10. So minus 2 minus 10 minus 12 by the total time 4, that is minus 3 meter per second square. That means it is also representing a retarding force. Some questions now on graphs. Which of the following is uniform motion? A very simple question. which of the following is a uniform motion? It is a distance time or position time graph. To any graph that represents a straight line inclined to the time axis, it would be representing uniform motion. So option A is the correct answer in this case. In option D, it is two different uniform motions. For the first half, it is a uniform motion. Then there's a break in the uniformity. The second half is again a different or a new uniform motion. The displacement time graph for two particles A and B are straight lines inclined at 30 degree and 60 degree with the time axis. 30 degree and 60 degree with the time axis. The slopes represent the velocity. The ratio of velocities of A and B is to be calculated. Slope is tan theta, so it is the ratio of tan 30 and tan 60. Tan 30 is 1 by root 3, tan 60 is root 3, so their ratio would be 1 by 3. The correct answer is option D. There's a figure, a diagram that shows the displacement time graph for a particle moving in a straight line. A displacement time graph is shown for a particle moving in a straight line. The average velocity from 0 to 5 seconds is to be calculated. Average velocity. Average velocity means total displacement upon total time. Average speed means total distance upon total time. Total displacement now can be calculated by the area of the graph. It is displacement time graph. So the total displacement is now to be calculated. How can it be calculated in this case? When it goes from 0 to 2 second duration, the displacement would be 20. When it goes from 2 second to 4 second duration, again the displacement would be minus 20. There is a mistake in the solution. It would be minus 20. So it is 20 and minus 20. 0, and the last one, the displacement would be minus 10. So it is minus 10 by 5, or the answer is option C, minus 2 meter per second. A ball is thrown vertically up. Which of the following plots represent the speed time graph of the ball during its flight if the air resistance is not ignored? If the air resistance is not ignored, we all know that when the ball is thrown up and when it follows a free fall, if we ignore air resistances, then what happens? But if the air resistance is not ignored, option C would yet be the correct answer. In the first half of the motion, the acceleration is uniform and velocity reduces gradually. Constant acceleration, gradual decrease in velocity. So it would be a constant slope. It would be negative, but for the next half acceleration, the slope would be positive. The shape of the graph is not changing because air resistance would also remain constant, providing a net new value of acceleration. It would not be g, it would be a plus g or g minus a of sort of, not, it is presented over there on your screen. Not ignoring air resistance means upward motion will have an acceleration a plus g, and downward would have an acceleration g minus a, but it would be again still a constant acceleration only, so the graph would still be C. A train moves from one station to another in 2 hours time. Its speed time graph during this motion is shown in this figure. The maximum acceleration during the journey. If it is a speed time graph, maximum acceleration would be in the region where the change in velocity is the most for the least time interval, where the slope is maximum, and that is visible in the region C to D. And slope from C to D can be calculated by change in y-axis upon the change in x-axis. Change in y-axis is 20 to 40, that 20 to 60, that is 40 kilometer. Change in x-axis, it is 0.25 hour. If I divided kilometer upon time, distance upon time, I get the slope as speed upon time. The slope is 160 kilometer per hour square. Option B would be the correct answer. This is a displacement time graph. You have to find its corresponding velocity time graph. The graph on the screen shows a displacement time graph, and you have to find its corresponding velocity time graph. For the first half, I can say the graph is bent towards time axis, and the graph is bent towards time axis, then it means it is continuously decreasing velocity. And for the continuously decreasing velocity, the only graph shown is the option A, where the slope is negative. After some time, at the central point, the slope becomes the displacement, the speed becomes zero. So velocity time crosses the time axis at that instant, and the second half is represented by the graph below the x-axis in option A. It would be continued further below the x-axis, below the time axis. So option A is the correct answer. A ball thrown vertically up, which of the following graph represents velocity time graph of the ball during its flight? This time the air resistance is neglected, but it is velocity time graph now. Means vectors are to be considered. So option D would be the correct answer. The velocity gets negative after reaching the topmost position. So option D would be the correct answer. You have to, once again, a ball is thrown vertically up, which of the following graph represents velocity time graph of the ball during its flight? Yes, option D is the correct answer. The reason is wrong. The option D is the correct answer. A ball is dropped vertically from a height D above the ground. It hits the ground and bounces up vertically to a height D by 2. Neglecting subsequent motion and air resistance, its velocity varies with the height h above the ground as. When the ball is dropped from height D, its velocity would be 0. But as the ball comes downward, height continuously decreases, increasing the velocity. So just before rebound from the ground, from the earth, velocity would be maximum. And just after rebound, the question says velocity reduces and it moves back into the opposite direction. The direction of velocity is reversed. And as soon as the height increases, its velocity decreases and becomes 0 at d by 2 because it is bouncing back up to a height of d by 2. These all conditions, they can be interpreted only in the graph A. Graph A represents the correct position of the given question. Option A is correct. In the next question, acceleration time graph of a body is shown. Acceleration time graph is shown and you have to find the most probable velocity time graph. For the first half of it, I would say where the line is inclined, acceleration is continuously increasing. Increasing acceleration. It is represented in VT graph. If I say the first graph shows the initial portion as constant acceleration, the second graph, it is bending towards the time axis, so it shows decreasing acceleration. The third graph is bending towards velocity axis, so it is showing increasing acceleration. The last graph shows constant acceleration, it is a straight line. So option C is the most probable graph in this case. Which of the following velocity time graph is not possible? A very simple and straight question. Simply just by looking at the question, you can see in graph D, at a given instant of time, two velocities are possible in the graph. So it is not a possible case. Option D is the correct answer. Velocity time graph of two cars, A and B, are shown in the figure. What are the four options? Initial velocity of A is greater than initial velocity of B, or acceleration of A is increasing at lesser rate than B, acceleration in A is greater than B, or acceleration in B is greater than A. Looking at any particular instant, everywhere the bend in A is more towards the velocity axis as compared to the bend in B, or I would say slope at any instant for A is greater than the slope at any instant for B. And in a velocity time graph, slope represents the acceleration. So acceleration of A is always greater than acceleration of B. So option C is the correct answer. Which one of the following graphs represent the velocity of a steel ball falling from a height onto a marble floor? Velocity time graph. Initially, when the ball is falling from a height, its initial velocity at time 0 is 0, and the velocity continuously goes on increasing as it comes down. After first rebound, its velocity again starts decreasing in magnitude. After the second rebound, it again goes on. So every time it rebounds, the velocity goes on decreasing, but the new velocity is less than the previous velocity because some energy is absorbed in collision with the ground surface. And this is repeated to the ball, or the steel ball comes to the position of rest. All these conditions, initial velocity 0 presented in all the four graphs, but the reversing of direction and decreasing velocity after every rebound is represented only in the graph A. It is the correct answer. The curve shown in the next figure is a velocity time graph. The graph shown is a velocity time graph of a particle, and you have to calculate the acceleration in the three fractions of the motion OA, AB, and BC. It's a velocity time graph, so acceleration is given by the slope. Slope is change in y-axis upon change in x-axis. For the first portion OA, change in y-axis is 0 to 10, change in x-axis is 0 to 10, so it is 1. In the second case, it is a horizontal line, the slope is 0. In the third case, change in y-axis is minus 10, final minus initial position. Change in x-axis is 20, so it is minus 0.5. Option A is the correct answer. A body A moves with uniform acceleration A and 0 initial velocity. Another body B starts from the same point, moves in the same direction with a constant velocity V. After what time would the two bodies meet? Suppose if they meet after time t as given in the question, distance covered by body A in the duration t is half at square. Initial velocity was 0, s is equal to ut plus half at square. So if u is 0, then distance is half at square. The second body is moving with a constant speed v. So there we calculate distance as vt. Distance is speed into time. Both the distances have to be equal in time t if they have to meet So the body would meet only when half AT square is equal to VT, that is T is equal to 2V upon A. Option A is the correct answer. A student is standing at a distance of 50 meters from the bus. As soon as the bus starts its motion with an acceleration of 1 meter per second square, the student starts running towards the bus with a uniform velocity u. Assuming the motion to be along a straight road, what is the minimum value of u so that the student is able to catch the bus? It's a condition, minimum value of u, so that the student is able to catch the bus. Suppose the student catches the bus after t seconds. So the bus would cover a distance u into t in those t seconds, or the student would cover the distance u into t. The student is running with a constant speed. So student will cover a distance u into t in that t second. But the bus is undergoing uniform acceleration starting from rest. So it would cover a distance half at square. Initial conditions, if we talk about, the initial distance was 50. So ut is equal to 50 plus half at square. Simplifying it, a is a, substitute the values, you can get the expression between u and t as u is equal to 50 by t plus t by 2. By mathematical calculations, if we want to calculate the value of minimum u, then you have to differentiate it and put it equal to 0. And as you do it, you'll get the value of t as 10 seconds, substitute it in the expression for u to get u also as 10 meter per second. A car moving with a speed of 50 km per hour can be stopped by brakes after at least 6 meters. If the same car is moving at a speed of 100 km per hour, the minimum stopping distance is. How to get the minimum stopping distance? A car moving with a speed of 50 km per hour, minimum stopping distance. Can we get the minimum stopping distance from the third equation of motion? V square is equal to u square minus 2as, as retardation is there. So you get it as the stopping distance formula u square by 2a. So we can say that the distance is directly proportional, the stopping distance is directly proportional to the square of the initial velocity. So s2 by s1 is u2 by u1 ka square, that is 2 ka whole square, that is 4. So s2 is 4s1, that is 4 times of 12 or 6. 4 times of 6, that is 24 meter. Option D is the correct answer. A body starts from rest with an acceleration a1. After 2 seconds, another body B starts from rest with an acceleration a2. If they travel equal distances in the 5th second after the start of A, then the ratio a1 is to a2 is equal to. By using the formula for distance travel in nth second, Sn is equal to u plus a by 2, 2n minus 1. Distance travel in 5th second can be calculated as a1 by 2 into 9. Distance travel in 3rd second can be calculated as a2 by 2 into 5. If we read the question again, then according to the problem, these two calculations that we have done, 9a1 by 2 and 5a2 by 2, they have to be equal, and that is why a1 by a2 can be calculated as 5 by 9. The average velocity of a body moving with uniform acceleration, traveling a distance of 3.06 meter is 0.34 meter per second. If the change in velocity of the body is 0.18 meter per second during this time, its uniform acceleration is. Time is always calculated as distance upon average speed. Average speed is distance upon time. So time is distance upon average velocity, and that is 9 seconds as per the question. Acceleration is change in velocity upon time. It is given in the question that change in velocity is 0.18. Time we have calculated as 9 seconds. So the acceleration during that particular period would be 0.02 meter per second square. A particle travels 10 meter in first 5 seconds and 10 meter in next 3 seconds. Assuming constant acceleration, what is the distance traveled in next 2 seconds? This is one of the big questions. Let us consider it to be in 3 different sections or 2 different sections. The particle travels 10 meter in first 5 and 10 meter in next 3. So distance traveled in 5 seconds. Applying second equation of motion, you get the expression as 10 is equal to 5u plus half a into 5 square. Equation 1 is framed as 2u plus 5a is equal to 4. Then in next 3, it travels 10 meter more. So total distance traveled in 8 seconds is 10 plus 10, 20. And second equation appears to be 2u plus 8a is equal to 5. We can solve the 2 equations to get the value of u and a as 7 by 6 and 1 by 3. And using the second equation of motion, we can calculate the distance traveled in next 2 seconds. That is 10 seconds distance can be calculated as 28.3. 8 seconds it was 20 meters. Subtract the 2 to get 8.3 meter. A body travels for 15 seconds starting from rest with constant acceleration. If it travels distances S1, S2 and S3 in the first 5 seconds, second 5 seconds and next 5 seconds, in every continuous span of 5 seconds the distance traveled is S1, S2 and S3, then the relation between S1, S2 and S3 is, since the body starts from rest, so u is 0 and distance traveled in any particular duration in such cases can be calculated as half at square. So S1 is half into a into 5 square, that is 25 by 2a. For the first 10 seconds, the total distance traveled is S1 plus S2. So S1 plus S2 would be 50a. There is 10 square into half a, that is 50a. So S2 can be calculated as this 100 by 2a or 50a minus 25 by 2a to get it as 75 by 2a. Similarly, we can get the total distance S1 plus S2 plus S3 in first 15 seconds as 225 by 2a. Subtract S1 and S2 collectively, that is 100 by 2a, from it to get 125 by 2a. And if we take the ratio of the 3, then we get S1 is equal to 1 by 3 S2 is equal to 1 by 5 S3. So option C is the correct answer. A body starts from rest. What is the ratio of the distance traveled by the body during the 4th and 3rd second? Distance traveled in nth second is directly proportional to 2n minus 1. For the 4th second, 2n minus 1, that is 2 into 4 minus 1 is 7. 3rd second, it is 2 into 3 minus 1, 5. So the ratio required is 7 is to 5 or 7 by 5. That is option A. If a body is thrown up with velocity of 15 meter per second, then maximum height attained by the body is. Maximum height is given by the formula u square by 2g. Straightway put the We'll use over here to get it as 11.25, option A as the correct answer. A ball is thrown vertically up with speed u, the distance covered during the last t seconds of its ascent. Distance covered in last t seconds. We can get it straightway as well. Distance covered in a time t during a free fall is always given by half gt square. So that can be the straightway correct answer. Option A is the correct answer. But if we want to talk of it with some other logic as well, ball is thrown up with some velocity u, then the time taken to reach the top is u by g. Velocity after t seconds, then u by g minus t second would be, we substitute in the first equation of motion, and then we subtract it through the third equation. You get the same answer, h is equal to half gt square. But if you know the concept, you can straightway mention it as option A is the correct answer, half gt square. A man throws balls with the same speed vertically upward, one after the other at an interval of 2 seconds. What should be the speed of the throw so that more than 2 balls are in the sky at any time? At any instant, there has to be more than 2 balls in the sky. That means minimum of 3 balls. 2 balls, at least 3 balls minimum in the air. Interval of throw is 2 seconds. So for getting 3 balls in air, the time has to be taken to be more than 4 seconds as the time of flight for the first ball. If it is 4 seconds, then only 1 ball or 2 ball would be in air. But if the time of flight is more than 4 seconds, minimum of 3 balls would be in the air at all the duration, at all the instants. So, and if t is more than 4 seconds, that means 2u by g has to be more than 4 seconds. That is time of flight for a ball thrown up. That means u has to be more than 19.6 meter per second. Option D is the correct answer. A man drops a ball downside from the roof of a tower of height 400 meter. Free fall, S is equal to half gt square. At the same time, another ball is thrown up with a velocity of 50 meter per second. Upward throw, S is equal to ut minus half gt square. When and where would they meet? As I gave you the expressions, if I split the two into h1 and h2, the distance of 400 meter, the total height is split into 2. If they meet at point P, then h1, distance traveled by the falling body, is half gt square. h2, distance traveled by the body traveling up, is ut minus half gt square. Add the two, you get ut, and that is the total distance 400. U is given to you as 50. So the time can be calculated as 8 seconds, substituted in the two equations to get the two distances h1 and h2 as 320 and 80 meter respectively. A very large number of balls are thrown vertically upwards in quick successions in such a way that the next ball is thrown when the previous one is at maximum height. If maximum height is 5 meter, the number of balls thrown per meter. Simply calculate the time interval between the two throws. If maximum height is 5 meter, then it means the ball is thrown with an initial velocity of root 2gh, that is 10 meter per second. And time interval between the two throws is the time taken to reach the top, that is u by g. 10 by 10, that is 1 second. So in a minute, 60 balls are thrown. Option C is the correct answer. A particle is thrown vertically upwards if its velocity at half of the maximum height is 10. I think this you can do very easily. The maximum height attained by it is, if a particle is thrown with velocity u and maximum height is h is given by u square by 2g. If the maximum height is h by 2 and the speed is 10, we have to mix up the two conditions. From equation 3, v square is equal to u square minus 2gh. we substitute the value of V as 10, U square minus 2G H as H by 2, I get U square is equal to 200. Substitute in the formula for H. U square is 200 upon 20. That is 10 meter is the maximum height attained. A stone is shot straight upward with a speed of 20 meter per second from a tower, 200 meter high. Stone is thrown up. It is made to move upwards. Speed with which it strikes the ground. The total displacement is 20. Initial velocity as it was thrown up minus 20. From the third equation of motion, you can get the value of final velocity V as 65 meter per second. Water drops fall at regular intervals from a tap which is 5 meter above the ground. The third drop is leaving the tap at the instant the first drop touches the ground. You have to calculate how far above the ground is the second drop at that instant. If the time interval is t, then for the first drop, half g into 2t whole square is equal to 5. Water drops from a height 5 meter above the ground. That is why it is equal to 5. For the second drop, x is equal to half gt square. If we relate the two, we can get that x is equal to 5 by 4. So the required height is total height 5 minus 5 by 4, that is 1.25, and that gives you the answer as 3.75 meter. Option B is the correct answer. A balloon is at a height of 81 meter and it is moving upwards with a velocity of, the velocity is missed over there, with a velocity of 12 meter per second. A body of 2 kg weight is dropped from it. The body will reach the surface of the earth in. You have to calculate the time period for it. If we apply the second equation of motion over here, S is equal to ut plus half at square. S would be 81. U would be minus 12, the initial upward velocity. If it was 12 meter per second, U would be minus 12. Time is to be calculated. Half. G is 10. And time is yet to be calculated. A quadratic equation is framed and it can be solved to get the value of t as 5.4 second. A particle is dropped under gravity from rest from a height and it travels a distance 9h by 25 in the last second. Distance traveled in nth second is given by 1 by 2 gn square. Total distance traveled in n seconds is given by 1 by 2 gt square, that is here 1 by 2 gn square. Distance traveled in nth second is given by g by 2 2n minus 1. Solving the two equations, you can get the value of h as, you can eliminate g and n in the two and get the value of h as 122.5 meter. Option B. A stone thrown up with velocity u from the top of a tower reaches ground. The same question that we did is now in the formula form. You will get h as 4u square by g. A body is released from a great height and falls freely towards the earth. Another body is released from the same height 1 second later. What would be the separation between the two bodies after 2 seconds of the release of second body? That means the position of first body after 3 seconds and the position of second body after 2 seconds. And they are to be subtracted to get the value as 24.5 meter. Motion of particle is described by the equation u is equal to at, the distance traveled by the particle in first 4 seconds. U is equal to at. If I integrate speed, I get the formula for distance or position. 80 if indicated leads to 80 square by 2, and the time is 0 to 4. The limits applied would be 0 to 4 second, and you'll get the relation as the answer as 8A. So option D is the correct answer. I think this is good enough for the day. Please be corona safe, use mask, maintain social distance. Thank you very much. Ma'am, you are not audible.
मैडम आपकी आवाज नहीं आ रही है, अब म्यूट हो गया, म्यूट हो गया। हाँ, चलिए, मैम की तरफ से कुछ इश्यूज हैं, मुझे लग रहा है मैम की आवाज़ हम तक नहीं आ पा रही है। थैंक यू सो मच हितेन सर, आपने आज भी पिछली बार की तरह इस बार भी बहुत अच्छी तरीके से जो कंसेप्ट से बच्चों के शुरू से लेकर के आखिर तक बहुत अच्छे तरीके से आपने उनको एक्सप्लेन किया, और ना केवल कंसेप्ट्स के जो एमसीक्यूज और जो इस तरीके के क्वेश्चन हैं उनको एक्सप्लेन किया है, बल्कि आपने साथ ही साथ जो डिफरेंट कंसेप्ट्स हैं उनको बच्चों को पहले से ही एक्सप्लेन कर दिया, जिससे उनका क्या है कि एक बार कंसेप्ट रिवाइज हो गया है। तो निश्चित रूप से बच्चों के लिए बहुत फ्रूटफुल सेशन रहा होगा, और फीडबैक फॉर्म लाइव चैट बॉक्स में शेयर कर दिए गए हैं। बच्चे सभी फीडबैक फॉर्म को जो है वो ज़रूर भर दें और अपना सर्टिफिकेट गेन करें। और थैंक यू सो मच हितेन सर, ऑन बिहाफ ऑफ 1 मार्क सोल्यूशन, ऑन बिहाफ ऑफ ऑल द व्यूअर्स, एंड डेफिनेटली हम लोग ऐसे ही साथ में जुड़ते रहेंगे, और डिफरेंट वेबिनार्स भी हमारे अपकमिंग हैं, शेड्यूल्ड हैं, जिसकी जानकारी आप हमारे ब्लॉग पर और हमारे इंस्टाग्राम पर भी देख सकते हैं। इंस्टाग्राम आईडी है 1 मार्क सोल्यूशन, ब्लॉग है 1marksolution.blogspot.com। जिन्होंने चैनल सब्सक्राइब नहीं किया वो चैनल जरूर सब्सक्राइब कर लें। थैंक यू वंस अगेन हितेन सर, एंड थैंक यू मैडम सीमा गंगराड़े जी, जिन्होंने आज के सेशन को होस्ट किया। आज हमारे लगातार 3 सेशन थे पैरेलल, तो सीमा मैम ने भी इसमें सहयोग दिया अपना आज के सेशन को होस्ट करके। थैंक यू सीमा मैम, ऑन बिहाफ ऑफ 1 मार्क सोल्यूशन आई वुड लाइक टू थैंक यू वन एंड ऑल। थैंक यू सो मच।
Thank you, sir.